As a kid, do you ever remember that one TV show that just always kept you coming back for more because of the ultimate realism, but still science fiction part of it? How about the movie where a science experiment went wrong and it made a normal person into a superhero, giving them powers that could never even be thought of? Or maybe it was even a book, jumping into the world of fictional, where anything is possible. Well, a lot of these things can actually be true, one of them being cloning. It's often depicted as an impossible science experiment, but now is a reality, developed through technological advancements and having the potential to help people around the world. Here I will be discussing the history of it, how it came to be where it is, the medical side of it, what benefits it has, and then finally going into what it can do for the animals. Cloning has certainly come from a long way where it started. Cloning began as a simple experiment of shaking two-celled embryos. In 1891, scientist Drix performed an important experiment, the separation of developing sea urchins. He discovered that if the sea urchins were separated at the two-cell stage, two complete but smaller than normal urchins would develop. Here, all he did was do a simple experiment showing how two things would become cloned. All he did was shake it. It was nothing big. But this, therefore, set the trend from years to come. Next, Robert Brigg and Thomas King, two scientists, transferred the nucleus cell from an early tadpole embryo into an enucleated frog egg, meaning a frog egg from which the nucleus has been removed. The resulting cell developed into a tadpole. This also set forth, the combination of these two set forth of what cloning has become and what the big moments that people actually remember of it. Both of these come from the history of cloning. After these experiments, scientists did research and tried time after time to clone mammals. Using a glass pipette as a tiny straw, scientist Brombaugh transferred the nucleus from a rabbit embryo into an enucleated rabbit egg cell. He considered this a success whenever the cell became the Molura, or an advanced embryo, that developed after a couple of days. Here, we can see the transform of just a simple reptile or amphibian going into the mammal stage of just a small embryo it's becoming. It was never a big process. Throughout the 1990s, multiple scientists at the Roslin Institute were trying to figure out how to clone sheep and other animals as a whole. And in about 1996, they actually tried this experiment one last time. There, Dolly the sheep was born. Dolly the sheep was a part of experiments at the Roslin Institute were trying to develop a better method for producing genetically modified livestock. You can see more about the pictures with going to thelifeofdolly.com, and also you can see all the things that she has helped from and what she did. She ended up having 6 kids actually. So Dolly has accomplished a lot in her lifetime, and this was a big milestone for the cloning industry. Cloning has opened a lot of new doors from the medical field, not only from the past, but even now. Using animals to conduct new research has done so many things and could do so many things in the near future. We can clone animals that typically carry certain diseases or defects in order to breed those out. These can easily help the animals survive longer, and even if we get this down to a fine art, can help us if we do it to ourselves. Genetically modified animals, we can genetically not modify animals, so that their cells and organs can be transplanted into humans. Take, for example, a pig heart. Pigs are normally used for experiments that need to be compared to humans, but in this example, we can say the pig's heart is close to a human's but not enough to be exact and replace it. Then we can use our DNA, modify the pigs, make clones of it, and therefore the pigs will then be transformed and we can use them as for us. This would bring up 2 major points if this was actually possible. This would fill the need of human availability for transplants, thus saving lives. Like I said, for the heart transplant, we would no longer have to sacrifice one human body and just to possibly save another. We can actually just sacrifice another pig's life and then probably save another, thus increasing the lives sustained. And the second big point of it, is diseases could be treated by transplants of genetically altered cells. So not only are we going to be altering the specific transplants, we can also be altering diseases that we have in certain things, such as your liver or your lungs. You can just put this genetically modified cells in there to purposely fight back. Cloning stem cells can have an enormous impact on transplants and medical procedures as well. Some researchers are looking at cloning as a way to create stem cells that could even potentially grow organs as a whole. So let's say you take a kidney transplant or a kidney donation because someone else needs one. You can then take DNA from your remaining one and potentially make it to where you have two kidneys again. This could easily drastically change the way that we do things now. Excuse me. Fertility problems could also be potentially eased with the use of genetic modification cloning. This child could have the DNA and qualities from both parents instead of just one, and having to get a sperm donor. This will completely eliminate that issue, even though this will bring up some moral issues potentially, but it does not eliminate the possibility of this happening. This comes from Cloning for Infertile Couples, which is an article written by a scientist and also a philosopher, both combined. Lastly, cloning can be used to save species. Cloning enables scientists to recreate endangered species and save them from extinction. Several wild species have been cloned already, including two relatives of the cattle called the gaur and the batnag, the mouflon sheep, deer, bison, and coyotes. All these were endangered and potentially could have gone extinct, but we cloned them to try to help save them from this, because there's been a lot of animals in the past, such as the woolly mammoth, which scientists are actually trying to bring back. Which leads me into my next point: we could possibly bring back extinct species. Now, this brings up the big question that everyone wants to know. Could we really clone dinosaurs? In theory, yes, actually. You would need a well-preserved source of DNA from that dinosaur, a closely related species that could serve as an egg donor, and a lot of money. In reality, this probably would not happen. And all of this information will come from Why Clone, the Why Clone article. This will not happen because it is very hard to get a very well-preserved DNA unless we thought that this was possible back then. But that does not stop us from trying with other species. In 2009, using goats as egg donors and surrogates, another group of researchers cloned the first extinct animal, a Spanish mountain goat called the barracudo. Now, he did not live for very long, however, due to a lung condition he was born with, which is just a side effect. But that does not mean that this cannot set the field for the future to come in cloning the extinct species and actually having them come back to life. Researchers are actually trying to bring back the woolly mammoth from the Ice Age, which could have a dramatic impact on the wildlife and everything in the ecology that we have today. Cloning endangered species is much easier because the surviving animals can now donate the living, breathing cells rather than us having to preserve the other ones. Now, if we take any living cells from species that we have, we can keep the samples, and then possibly do that for the future, so we can start preparing for that now. So take a moment and breathe and think, what if we lived in a world where the impossible was possible, where we can look outside our window or go on a trip and see a woolly mammoth, or possibly a saber-toothed tiger, or any other extinct species that you could think of? Well, this is the possibility with cloning. Cloning can help solve many problems, whether it be with animal species, it can help solve human medical problems, and it's come a long way from where it was, but that does not mean we do not have a long way to go from here on out. Thank you.